All right. And people will start to shuffle in. But hello to everybody who's sort of trickling in. Welcome to another another episode of CSINext monthly webinars. We're going to have a really great presentation today from Doug Steimle, and he's going to tell us all about this great project and the use of mass timber in it, and it's going to be really exciting. So I'm just going to let everyone sort of trickle in, and those of you who have experienced my emceeing style before know that I usually do a little snappy patter and spin for about 5 minutes to give everyone a chance to come in. So I'm really glad to see folks, and welcome, welcome, welcome. So Doug, where are you physically located?
I am in Cincinnati, Ohio.
Oh, nice.
I'm wearing my Bengals jersey, or not
Oh,
jersey, but Bengals shirt. Go Who Dey, right?
there you go. All right.
Longest drought of a playoff win of all major sports.
Oh, well.
1991 would be the last one. They,
That's the kind of statistic that you really want to be broken as soon as possible. So,
we're living the Bo Jackson curse because we hurt Bo Jackson in that last playoff game that we were in that didn't win. Right after we won. So.
fun and games. So how's the weather there? Are you guys getting snow, or are you guys getting cold, or are you having one of these warm snaps that everyone's having?
It's relatively warm. It's around 40, 45 degrees today.
Okay. Well,
But
that's kind of warm for January. Yeah.
yeah, but snow, we hardly get any snow here. It's
That's
kind of
not
sad. It's kind of sad.
well. That's yeah. I'm up north, so that's not really the problem with me. So
Right.
anyway, I hope everybody who's filing in is having a great week so far. I don't know about you guys, but I always find the first couple of weeks after we come back from the holidays a bit challenging. It's all of a sudden everything starts up again, and I'm never quite ready for it. But just so that everyone is aware, we've got a bunch of great presentations coming up. So please mark your calendars. The second week in February, we've got a presentation on uh, 3D real life imaging, getting into rendering and that kind of stuff, which should be really fascinating with Dan Berenger. In March, we're going to have the new architectural casework standard from AWI. They're going to present on that and tell us all about this new fabulous standard. In April, we've got how enriching spaces became the healthiest building in Ohio from Don Schwartzman and Yasha Egg. And then in May, we've got Keith Robinson, who's going to, and we've tried to have Keith a couple of times and we've had some problems, so I apologize, but he's probably good. He's going to finally present on bridging the gap between Division 3 and Division 9, concrete finishes, moisture, stuff like that. So we got some great presentations. So second Thursday of the month, be sure you note it on your calendar for CSINext presentation. In the meantime, as we are getting on, I would love to introduce our speaker. We have a great presentation today, and Doug Steimle, who's the principal at Schaefer. He was challenged by his firm's vision to lead the field in wood construction, and they've become a thought leader in cross laminated timber. In partnership with Nordic Structures and other firms, Doug designed the first CLT hotel in the US for Candlewood Suites in the Redstone Arsenal. With over 30 mass timber projects now complete, he's going to break more barriers with CLT and tell us about all sorts of other exciting projects he's got on the board. So we're looking forward to a great presentation from him. And I'm just going to give about 2 more minutes, and then I will unleash him upon our eager listeners, our eager audience. So you guys are getting a lot of CLT and mass timber work then that's coming at you, it sounds like, Doug.
Yeah, quite a bit. So most of the work that we're involved with is not as the engineer of record, because in order to be the engineer of record, you have to have the relationship with the architect and the client, and you know, I only have relationships with so many people, but you know, 5 or 6, 7 of the projects that I've been involved with have been as the engineer of record, but
Nice.
many of them have been as involved as the specialty engineer designing the connections from beam to column, or, you know, beam to beam. A lot of weird stuff going on.
And designated design and the specialty engineer, it's always a really interesting relationship. I'm working through it on another project of mine where we're doing the same thing with some precast concrete panel construction, and it's always a challenge, kind of delineating what's the scope of your structural engineer of record, what's the scope of your specialty engineer, and how do they interface.
Right,
It can be a challenge.
right.
So
Yeah, and in this type of construction, specialty engineers are really critical because, you know, each manufacturer wants to put together their structure a little bit different, and it's hard for the engineer of record to know exactly how to design it, to put it together.
absolutely.
So,
Well, we are at about 5 after. So, Doug, I'm going to turn you loose and let you start. I'm going to mute myself and turn off my camera. If at any point during the presentation anyone has questions or things to ask Doug, please throw them in the chat, throw them in the Q&A. I'm going to be keeping an eye on that and let Doug know what those questions are as we go through. And he has been very kind to allow us to ask questions all throughout his presentation. So when he stops to draw breath, I'll be peppering him with questions. So, all right, Doug, take it away.
all right. Well, thank you, Catherine. Thank you for the opportunity to speak with you guys today. And yeah, I do like to have interactive. Obviously, being remote and not being in the same room with you is less than ideal, but you know, if we can make this as interactive as possible. If you're thinking of a question, someone else is probably thinking of it too. So let's have some conversations. But yeah, I'll be talking about specifically about the I won't be talking about all 30 or 40 projects that I've been involved with mass timber wise. I'm only going to be talking about a few of them, but specifically going to be focusing on the first one that we did, because there's a lot of comparisons between it and a similar light gauge building that was built by the same team, same owner, I should say. And so some good takeaways there that we're going to get into. But certainly, as you mentioned, Catherine, mass timber is certainly on the rise, and this is really more about a mass timber presentation, but specifically going to be focusing on cross laminated timber a little bit more than everything else. And that I want to get into, you know, some of the pros and cons of it specifically. And in fact, it's why I've gotten involved with mass timber. I've designed lots and lots of wood buildings that are not mass timber, that are just stick built, and this piqued my interest, and I'll show you why. So again, Candlewood Suites. This is actually on the Redstone Arsenal, which is a U.S. Army base down in Huntsville, Alabama. That's where this project is. We're going to learn about its material strengths, labor advantages, things like that. So why would we want to use this on future projects? I do want to mention, well, you know, cross laminated CLT is cross laminated timber, and I'll get into describing exactly what that is. We're gonna address all kinds of aspects of what cross laminated timber is. But again, I'm going to assume that you know nothing. Hopefully, even if you do know something, that you'll get some things out of this, I would imagine. This is an AIA presentation, so please get me your stuff. Now, I just realized earlier this week that the AIA accreditation has expired, but I'm in the process of getting that back. So it's usually a day or two or a week before I get that back. So I'll get you
We'll
your
get you
credit.
all. I'll get you all the numbers and everything for everyone that's registered for the presentation.
Perfect. Sounds great. Like I said, it might be a week or so, just depending on how fast they get me back into the right graces here. But it shouldn't be a problem. This has been accredited in the past. So anyway, here are the AAA required learning objectives. We're going to consider potential applications for using the cross-laminated timber. We're going to talk about the Redstone Arsenal and how, you know, the various different things like schedule and site labor constraints all made it a reasonable material to use on this project. This project's interesting in that it was, again, on the U.S. Army base and had to be designed for anti-terrorism blast protection and progressive collapse. I'll probably skip over that relatively quickly, but then we're going to take some lessons learned from that project and kind of where things have moved since then. So, cross laminated timber, here it is right there. So commonly known as plywood on steroids. The difference between cross laminated timber and, say, glue laminated timber is that the material goes back and forth in a crisscross manner. Glue laminated timber would have all of the members in the same direction, usually the same grade. You know, it could be different grades of lumber and things like that, but essentially the same lumber, same glues. It's just how it's laid up. But cross laminated timber then can be manufactured, depending on the manufacturer, 10 feet wide, 65 feet long. You know, not everyone does those dimensions. In fact, I don't know that anyone does 10 by 65, but 8 by 65, yes, or 10 by 40, yes. But so again, part of the reason why we need to really make sure we know which manufacturer we're kind of dealing with. So going into exactly what cross laminated timber is, the kind of the process of it is, you know, one of the most important parts is this very first piece where it's talking about kiln drying the lumber to 12% plus or minus 3%. Shrinkage is a big deal. We're going to talk about shrinkage and wood shrinkage for a good chunk, just because, again, one of the benefits of mass timber is it doesn't shrink a whole lot, which is great. But that 12% is important. Typical kiln dried lumber, when you're buying it, is around 19%. So this is dried to a much lower moisture content. Then the material is graded, whether it's visually or machine graded. And then it's finger jointed so that you can have a continuous stud as long as you want, and you cut it to the right length. And then you put layers of glue down between the two. You pressure pack it, and then you cut it to whatever shape you want. And so that the precision of that cutting is just amazing. It's far more precise than really any other material construction out there. Steel, concrete, light gauge wood. This is obviously wood, but I'm talking about thick built wood. This is very, very precise. In fact, one of the challenges of mass timber construction is how precise it is and how not precise the concrete foundations below it is. So you need to, you know, build in some flexibility there between the two. So where is this in the code? It's actually in the 2015 code, and it's under, you know, it's under type 4 construction. I'm going to skip through that relatively quickly, but it's also in chapter 23. Chapter 23 references the APA PRG 320. That is the actual document that's used to define what cross laminated timber is. There's actually a newer version than what I've got shown there, but that's what defines what cross laminated timber is. So if someone wanted to just off the street say, hey, I've got some cross laminated timber for you, well, it would have to meet those specifications. So it's also, so these are the main resources associated with cross laminated timber. There's a CLT handbook. It is a free download, as is the PRG 320. The document here on the top here is the PRG 320. Free download for that as well. The NDS is not a free download, but there's information in there regarding mass timber as well. Cross laminated timber, I should say. This is in fact a sheet, and then images out of the NDS with cross laminated timber is one of the chapters in there. All right, I love this slide. So warnings against cross laminated timber or mass timber, really, for that matter. It's not necessarily CLT that this is about, but these are actual ads that I've seen, and there's a little bit of fear mongering going on with the Concrete Tilt-Up Association. They're trying to scare people away from using mass timber, and specifically code officials from voting in the 2020 for the 2021 IBC. If you guys are familiar, so this has already happened. The 2021 IBC is finalized, and there's huge changes in it, specifically regarding type 4 construction. So type 4 construction as it currently stands can go 6 stories tall. Prior to the 2021 IBC, it's taken the type 4 and turned it into 4 different categories. So there's the HT is what it once was, and then there's the A, B, C categories, and I believe the type 4A corresponds to type 1A for, so all the fire ratings you would have on a column, beam, sort of that sort of a thing, they match. And of course, type 1A construction is non-combustible and allows you for unlimited height in areas. The areas for type 4A and height limitations go much higher as a result. And B then is a little less restrictive, and C is even less restrictive. There's nothing allowed to be exposed in A. There is some allowed to be exposed in B, and even more allowed to be exposed in C. And of course, HT is what it currently is, or what it typically has been. So this allows you to go up to 18 stories tall with wood without doing any exceptions to the code. And of course, there are buildings out there that go even taller than that, or are getting built to go taller than that. So an authority having jurisdiction could say, yeah, we can go taller than that. And the reality is that the people that were looking at this initially thought there is no real reason why we're not. They just arbitrarily put it at 18, 12, and 9 for the height limitations for those 3 different ones, just to, again, kind of break people into the idea that you can actually go taller with mass timber, both from a strength and a safety perspective. So pretty crazy, huh? Hopefully you guys already all knew about that, but if you didn't, it really opens the world of mass timber to a lot of different new projects now that you can go much bigger with it. So this is a map of North America, and it's showing the different manufacturers in North America. And I'm not going to claim that this is an all-inclusive list. In fact, there's one on there, Katerra, which they're out of business, and I'm not sure what happened to their plant, if they've sold it or what, but or if maybe they're coming back in business. I don't know, but Structure Lamb is a major manufacturer on the West Coast, and they also just opened a plant in Little Rock, Arkansas. And then Nordic is probably the biggest one on the east side of the North America. And Smart Lamb is a little bit smaller. They've got 2 different plants, but they don't do as much. And then DR Johnson's even smaller than that. Structure Craft, I don't believe they do any much manufacturing themselves. I think they do manufacture Dow laminated timber. I'm not exactly sure what they do, but I think they more buy other people's product and then they design and they do a design build product. But then there are also, I didn't include anything here, but there are also European manufacturers who absolutely play a piece of the market here in the US as well. So I just left them out for
Doug,
simplification.
given the current supply chain issues that are going on, are you aware of any problems with our manufacturing friends in Canada or from Europe getting things to American job sites? I'm just curious myself because it's coming up in so many other areas.
Yeah, right. To my knowledge, no, it's not been an issue. Now there are only so many of them, so it's not like you can just go down to your local Home Depot or Lowe's or whatever and buy some off the shelf. So you got to get in line, and there it is popular, and so it's not like they're just fiddling the drums waiting for you to give them a project. But that being said, it does take a little bit longer on the pre-planning side of these things, because everything comes together and fits together like Legos, like everything. There should be no cutting on site of anything. So that means that there's more pre-planning, but then you save time in construction and then labor by doing it that way. But great question. In general, I think the answer is no, but I can't speak for everyone. I do have done quite a bit of work with Nordic, and I don't believe it's impacted them at all. So,
Nice. Good.
and I have talked with the other ones as well, and at least as of the last time I talked with them, that it is not an issue. But here are some of the different capabilities I mentioned as far as strength. I'm sorry, not strength, but panel sizes that they can fabricate. Again, these are probably changing as well, over time as they get new equipment and stuff like that. So again, the point is check in with your local manufacturer to see what they can do, or whichever manufacturer. If you're going to do work on a project, check in with the manufacturer to see what you've got. So this is a sheet of showing, this is right out of the PRG 320, and it's showing the different grades and different material types of cross laminated timber. The E would be for electronically graded, the V is visually graded, and the 1, 2, 3, 4. There's actually more than that at this point in time. So this is a chart from an older PRG 320, but those are just different types of lumber. I don't remember which one's which, so there's like hump fir, there's Doug fir, there's spruce pine fir, there's southern pine. And I don't know, I think there might be Alaskan yellow cedar potentially. But again, it's really just different manufacturers. And then it's also showing you layups, standard layups. Now, when I say a layup, I mean cross laminated timber will be 3 plies or 5 plies or 7 plies. Are typically odd numbers, and the plies are typically 1 3/8 inches thick. However, every manufacturer can modify that and then have their own versions of what they provide. So they might have 2 different thicknesses of 5-ply material, one using everything at 1 3/8, one maybe the middle plies are only inch thick or something like that. So it got thinner overall. And so ultimately it's trying to save board feet, use the right material for the right project. The thinner you can get for this material, you save, hundreds and hundreds of thousands of board feet. So it's really critical there. These are a couple of charts that are no longer available on either one of their websites. This is, I think the one on the left, the one on the left used to be on Nordic's website. They don't even have so it's showing 78 millimeters 3-ply, 105 millimeter 3-ply, again, showing you 2 different 3-plies, 131 millimeter 5-ply and 175 millimeter 5-ply. I believe they still have the 105, 131, and 175, but they now have an 89 and not a 79. But point here is this is allowable bearing for if you're going to use it as a wall. I wanted to just point out that it's really strong. Like if you had the 105 is basically 4 inches thick and 10 feet tall, that's allowable capacity is 30,000 pounds per lineal foot. That's a lot of load. The one on the right is structure lam. Again, I don't think they have this on their website anymore. So I stole this quite a while ago. And that the 3-ply panel 10 feet tall was 21,000 pounds per lineal foot. So strength is usually not what's governing these panels. It's usually connections that's governing it, or from a wall perspective, or from a floor perspective, it's vibrations, not necessarily, again, not strength. All right, I got a poll question here, so maybe type into your thing, or if you want to unmute yourself, you can. In Brave, and you want to say the answer to this. Which shrinks more, wood or concrete?
I'll give you the political answer, which is it depends.
Oh, so why would you say it depends?
Concrete shrinks more initially, but after the 28-day cure, I think it's it stabilizes. Wood, I think, would would react more to environmental conditions, ambient humidity, heat, things like that. It's more of it's an organic material.
Yep.
It's a living material.
Yep. Okay. Well, you nailed it. It depends. Now, from a concrete perspective, it actually continues to shrink quite a bit over the first year or so. So it might be 90 days or so that maybe 50% of the shrinkage happens. But you're right. It shrinks more early on. Now, wood though, um, it shrinks dependent on how much moisture content changes. And you kind of mentioned that same thing as well to a certain extent. The relative humidity in the air. But so the interesting part is, most softwood lumber, which is what we build materials out of, and which is all the cross laminated timber is made out of, it has a 30% moisture content in it, plus or minus, when it is cut down. So 30% of the weight of the wood is moisture, which is why we kiln dry it to get rid of a lot of that moisture out of the wood. And so kiln drying it down to 12% means that 18%, most of the moisture has been taken out. Now, wood shrinks an awful lot in the tangential and radial direction. So 4.5, if you lost all 30% of moisture content, 30 down to 0, it's going to shrink, 4 to 5% in the radial and 7 to 8% in the tangential, but very little, 0.1 to 0.2% in the longitudinal. So along the length of a tree, it hardly shrinks at all.
Doug, I have a question for you. And
Yeah.
this is something that's come up with me for working with certain types of wood that have been dried and then chemically treated, or dried and had processes done to them, that when the moisture content is reduced down below, to a fairly low thing, that sometimes when they get put back into a humid environment, there's some warpage, there's some cracking, there's twisting.
Mhm.
Has any of this been an issue? Now, I realize that cross laminated would sort of brace itself against that, but I'm just curious as to if you started building with this in Miami, in an extremely humid environment, or in the South, are you going to have any warpage, any shrinkage, any cracking from
That's
that reaction?
that's a great question. I have a picture that'll tell you the answer to that here in a minute, and
Okay,
I'll refer to that one here in a second, because
excellent.
that's a fantastic question. So you bring up a great point. This chart here, I believe this is out of the Wood Handbook, is shows the relationship between relative humidity and moisture content in a wood. So the drier the environment is, say out in Arizona, your relative humidity is going to go way down, and therefore your moisture content, your final moisture content in wood is also going to be way down. Whereas in somewhere like Miami, the relative humidity is much higher, and your final moisture content in your wood is much higher. And depending on the season, here in Cincinnati, it's pretty dry right now, so the moisture content in the wood is probably getting close to 6% or 8%. Whereas during the summer, it's going to go up to 12%. So it is going to get thicker and thinner depending on the season. So that is a great point you bring up there. And so to answer your question here, my next 2 slides will show you that. But I did a shrinkage calculation on this 4-story building. And the great part is if you're drying down to 12%, then you don't have that much more to shrink, because you've already lost most of the moisture content. So if you're coming down to a final moisture content of 8%, then you don't have that much shrinkage that actually happens. Most of that shrinkage has already happened. So from the thickness of a panel, so the thickness of a CLT panel, for every 10 inches thick, you'll shrink about 0.1 to 0.2 inches, so not very much. Now, along the horizontal dimension, though, of a panel, like or along that 60-foot length, if it's 100 feet long, you're only shrinking 0.04, because that dimension is restrained by the glue and the length of the tree, say, right, the longitudinal direction of the wood. So the takeaway is that concrete shrinks way more than steel, or I'm sorry, than wood. But all right, so here's a picture that I was getting to, this is our conference room in Cincinnati, Ohio. The Ohio River is just to the left. You can see the bridge in the background. But this is cross laminated timber table, and this is a close-up of the end of the cross laminated timber table. When this came to our office, the wood hadn't shrunk at all, and so there was no gaps. These gaps didn't exist, but now these gaps are there, and they're actually fairly wide right now. And but you can see they're V-shaped because they can't get smaller here because it got glued to this member here, which isn't hardly shrinking at all in this direction. So
So
this
this
is
would be
very
more of an,
dimensionally stable.
yeah, sounds like this would be more of an issue for places where you have exposed surfaces that you're using the beam as a decorative element. Maybe you're using it as an architectural signature piece to divide spaces. You could conceivably have these cracks opening up.
Yeah, you would definitely see these things. So if you had it as a wall, you wouldn't ever want to use this as the finished floor. Now a finished ceiling is fine, but you wouldn't when it is the finished floor. And for that very reason, you don't glue these joints at all, because if you glued the joint, then you end up with a crack that's crooked down the middle. It doesn't hurt the strength of it, doesn't help the strength of it. You know, so yeah, these gaps will open up for sure. So that table that I referenced here, it's not the greatest if you have plans out and you're trying to draw on it or whatever. You got a lot of ridges going on there, but it's great from a looks perspective. Anyway, so if you had it as a wall, you would definitely have those joints opening up, and you would have to live with that. Now something like glue laminated timber, you would not have that. So because everything's running in the same direction, everything is glued together there. But you can potentially you have shrinkage that happens along the length of that, so you have other issues to kind of deal
which
with.
brings up an interesting question. Are they ever used together? Do you ever use glue laminated and CLT in combination?
All the time. Yes, they are meant for each other, like chocolate and peanut butter. So yeah, absolutely. They most of the, I don't know if there is any manufacturers of cross laminated timber that don't also manufacture glue laminated timber. So they would come from the same place and they would be part of the same shop drawing process. And so they would go together. But again, you have to consider the fact that glue laminated timber is going to shrink differently than the CLT. And but as long as you're keeping those things in mind, and they go together really well. So this is kind of a shrinkage calculation that we did on this project. The total building we anticipated to shrink 0.2 of an inch, whereas a typical 4-story wood building would shrink about an inch, about 1/4 inch per story. So that's significantly less, which is one of the reasons why I got interested in this in the first place. This is during construction. It was 18.1 moisture content, because this was actually during up in another project, Fort Drum, and Fort Drum is in upstate New York and had lots of snow, but the underside of it had almost, it was normal moisture content, what you would expect. So the question is, did the cross laminated timber swell because it got a higher moisture content in the top? The answer to that is no. This is a picture kind of showing the thickness of the CLT was 6 7/8. That's how it was manufactured. And as you can see in that picture, it is really close to 6 7/8, maybe a 16th inch that it grew. So, the amount of shrinkage is still minimal. Essentially, the wood is a bunch of straws, and the water wants to go in the end grain of those straws. So it would want to come in kind of down in here, not so much sitting on top. It doesn't really penetrate much of the wood going straight down through the top. So didn't really affect the moisture content overall. So now it's time for some pretty pictures. This is the topping out ceremony. It's funny that there's so many people standing around there, but there's really only 10 or 11 people typically working on the project. But everyone wanted to be there for the topping out ceremony. Here's the design team. I'm gonna kind of flip through that real quick. But these are some of the main reasons why you would want to use mass timber or cross laminated timber: acoustics, building performance, speed of construction, dimensionally stable, like I mentioned earlier, extended construction season, less labor, less weight, less foundations, less cranes, highly mechanized. I can't say that. Production. The reduced on-site inventory, meaning that all the product comes at the time that you need to just put it into place. Not every manufacturer does that. Not every project like that happens like that, but you certainly can plan it so that the product gets there just in time and you erect it just in time. Now, if you get it from Europe, that's not going to happen. It's going to come in a bunch of shipping containers, and so you're going to have to figure out how to get everything out. And they can still put it in to a certain order, but it's not going to be the just-in-time kind of a thing. You just need a bigger site. But it does use carpenters, the conventional tools, nothing crazy going on there. It's a very safe project as well. So Lend-Lease, who was the developer on this and also the contractor, kind of had some good, nice takeaways. They basically said, if you have 3 or 4 of these conditions, you should consider mass timber as a possibility. It may make sense. So schedule constraints, labor scarcity, labor costs, those are very much related. And then poor soil foundations, because you're going to have a lighter building and therefore you can save some money on your foundations. In general, I don't think mass timber does a great job competing with in the 1 to 5 story world. If you're talking just pure cost of construction, stick built wood framing is always going to be cheaper than this. But once you start getting outside of that realm, 6 to 10 stories or even taller, then it really starts to make sense. It's meant to compete with steel and concrete structures, not with stick built wood structures. Here's a picture of a cross section showing the acoustics. Everything on this project, unfortunately, was covered, but it did end up helping out with sound ratings. They were looking for an STC rating of 65, and in the field they actually got 70, which is pretty amazing. Usually it's the other way around. You don't get as high as you're shooting for.
And STC ratings can be very tricky. If anyone who's ever had to do a high STC rating knows that they can be ugly.
Yeah. Yep. So here's a picture of a shear wall hold down. So we mixed in some steel to kind of tie things together. We did design for blast and progressive collapse. I don't know if anyone here cares much about that, but just real quickly, the blue areas are what we had to take out chunks of wall, and the building had to still stand. So chunks of wall, a story at a time. If you took out a ton of it, then obviously no one expects it to survive. But if it's a relatively small blast where it's taken out part of the building, then it's meant to survive. So we took out a chunk, and believe it or not, it was relatively easy to make it work because it's basically a big beam. We just had to stitch it together really well. This picture kind of shows some of the shop drawings and the stitching together, but I realize you can't see that, so just take my word for it. We just had to stitch it together. All right, so here's some pictures of the stair shafts going up. This is something where I think is a great application in general for mass timber. You can get the fire ratings pretty easily with it, and it goes up relatively quick. Here's a picture of the glue laminated timber columns, glue laminated timber beams, and cross laminated timber walls. On this project, there was far more cross laminated timber walls than we probably needed to have, but that's what the direction of the owner wanted. They wanted to go all in on this. But like I said, we mixed and married cross laminated timber with glue laminated timber. You can see all the holes pre-cut in the beam. So if we can make that coordination ahead of time, get all the MVP figured out, then we can get that all cut in, and they can run it right through those areas. You can certainly also mix and match steel in here, as you can see. This could have been glue laminated timber going across there. That wouldn't have been a problem, except it would have been deeper, and then headroom would have been a problem. So sometimes it makes sense to mix and match in some steel as well, although it's less desirable to have steel involved, because sometimes you need to then have steel manufacturer. If your glue laminate, if your wood manufacturer can't do the steel themselves, then it's probably not what they do. So it just more cooks in the kitchen makes it a challenge. Here's some more pictures wood of cross laminated timber being flown in. There's a picture down showing all the walls down the corridor. There's a picture from the underside of the stairs, because the stairs themselves were very dirty. Much prettier from the underside. Here's a picture of a floor. So these, you can see the splines in terms of how the panels are kind of tied together. So the splines are typically they route out either 1/2 inch or 3/4 of an inch to allow for you to put a piece of plywood in, and then you nail the plywood down to either side. And that's typically how they get fastened together to create your diaphragm. They get the load to the shear walls through the very stiff floor there. They obviously put waterproofing on it to try to keep the water out from the building down below. Here's pictures of a ton of screws getting put in. As I mentioned before, we were designing for blast. Blast is very high loads, and so this is way more screws than a typical project for how you would fasten them together. But it
How
was
long are those screws? I'm just
well, you can get screws that are very long. These would have been, let's see, 7. These would have been probably 12 inches long.
okay. It's just the perspective of trying to get a sense of scale from that picture, and it's
Yeah, right. So the panels that were used here were 7 inches thick, or 6 7/8. So you need 7 inches to go through that, and then probably 4 inches or so into the panel below, the wall below. Yep. And then we did the same thing coming up. So it had a lot of screws on this one. Here's a roof showing kind of, we did cantilever up the walls. Now the really tall walls, we didn't cantilever up. We had structure behind that bracing it, but the shorter ones are just pure cantilevers up. There's a picture from the outside. And there's a finished picture. I love this one because you can tell the different color of grass. Some of it's really green, some of it's not. And that's because grand opening was in the wintertime, or maybe springtime, I believe it was, like end of March or beginning of April. And so they spray painted the grass green to make it look good.
no one ever does that for publicity photos or anything like that. No,
Yeah,
I
right.
don't know what you're
Well,
talking about.
right. Given the high profile nature of it, right? That first government building built out of CLT. So yeah, it's they wanted to play it up big. So here's a time lapse video of it going up. You can see the first stair go up. Now the first stair, I think, took them 18 to 20 hours to put up. The second one, I think it was 14 or so hours, and the third one was like 8 hours. So they definitely were learning on the first one, and they got started to become much faster. As I mentioned, speed of construction is important. And so one of the things they did to increase speed of construction was, if you see those white panels that are popping up across the screen, those are actually pre-manufactured bathrooms. So those are going in as they're going up with the floor, and then they basically have finished bathrooms done. They just have to hook up the plumbing above and below real easy, and I think hook it into the electric, and they're done. They have finished drywall, painted, light fixtures, bathroom fixtures, all in there. So certainly helped with the speed of construction.
Was this particular contractor experienced using CLT, or was this his first job using CLT and he was learning as he went?
First job. And they spent quite a bit of time learning. And when I say they, it was, there was the wood mafia group of about 5, but the two of them were actually the guys kind of leading the construction end of things. I call them wood mafia. They're my friends. So but they're good guys. But the interesting part, that's a great question. So I mentioned that there's only 10. So here's the takeaway that I was kind of, one of the good takeaway slides here is they compared this building to a 54,000 square foot light gauge building that they also did similarly. And our building is 62,000 square feet, so it's 14% bigger. But the average number of employees was, 43% less on ours than the other projects. So that was up to 26. We were up to 11. The structural duration was 123 days for the smaller building, and ours was only 78 days. So that's a significant savings. The man hours were way down, 14,700 to 8,200. And so the production per day was way up, and they saved 3 months total on the schedule. So that's significant. I don't know any owners that wouldn't love to do that, save 3 months on a construction schedule.
Nice. Do you happen to know who did the bathroom pods? I have a question if it was Pivot Tech, but
it is Pivot Tech. Yes, they're local here in Cincinnati as well, believe it or not.
Somebody was asking, since you are from Cincinnati.
Yeah, I think it was just a coincidence though, because I'd never worked with them before that project. So I don't know exactly how everyone married up, but it worked out all right. It worked out really well.
Now, one of the things that I'm curious about is essentially you've got a solid wall structure. So electrical conduits, things like that, how are those are those running on the surface of the walls, or are you furring them out, or are you getting to that?
So those, if you go back to the architectural section that I had shown, it would run through the furred out portion of the
Okay.
walls.
So yeah,
or
they
through the
used a
ceiling.
little bit of a furring channel there, and okay.
Yep. Great
Because
question.
nobody really likes surface mounted conduits.
No one does like that. At least no one that
No
I
one
know.
that's going to admit it.
Right. So getting back to your point about the labor, and at the very bottom here, one of the things that they were very proud of. So on a U.S. Army base, it's really labor scarcity is a challenge, because not just everyone can go onto the U.S. Army base. So they used eight of their 10 people, I believe, were unskilled veterans that they upskilled. So they didn't know hardly anything about construction. So it wasn't just that it wasn't an experienced contractor before this. It was 8 of the 10 people didn't know anything. They could listen to instructions well, and they were hard workers, and that's all it took to build this thing well and build it fast. So what's next? What's key here is that we keep the initial cost low, the operating costs low, speed and efficiency, acoustics. I'm gonna go to this project here, Fort Drum. We eliminated a lot of the CLT interior walls on this one. We kept all the exterior ones from a blast perspective because they work really well for blast. But on the interior, we got rid of most of the walls and just used stick framing, but still used cross laminated timber for the floors. Here's some pictures. Again, kind of zoom through them. This is kind of a roof that cantilevered out. Got to go out to the site. That was in 2018. But going through a few other different projects now. So this is Michigan State University. This one can kind of open up some doors there. You can see, so for lateral load, there were no CLT at all used for the walls anywhere. So it's just columns, and what you can see in that picture is steel columns. The lateral bracing system was just steel X bracing. Sometimes the steel columns, sometimes the wood columns, sometimes the steel beams, sometimes the wood beams. But what you're seeing there is the wood. Here's another project. This is a 3-story office building in New Hampshire called the Arboretum. And it had no CLT walls on the exterior, but the shaft walls on the interior were all cross-laminated timber, and that is the entire ladder load resisting system for that building. Column grid on this was 20 by 25. So you had beams running in one direction, cross laminated timber running the other direction. Was
You
very
mentioned
efficient building.
you mentioned shafts, and I'm just curious. Are they running elevators in these structures? Have you run
Mhm.
elevators through laminated timber shafts? And
Yes.
is that a concern? Because elevators are notoriously fidgety.
No, not a concern at all. Yes, we did both of these projects. The ones that we're talking about all had. I don't know about the MSU project. I don't believe that that was in a CLT shaft, but all the other ones are CLT elevator shafts and stair shafts. Yes.
Hmm.
Yep. Works great. So yeah, there's a lot of possibilities. This one's really cool. This one's down the road from me. I've been to this one a number of times because I can drive to it very easily. In fact, it was getting built towards the end of COVID, so that I had a number of date nights with my wife just driving up there when there was nothing else to do. But it's pretty neat in that it's 80-foot long glue laminated beams that are approximately 5 to 6 feet deep because it's sloping all the way across, and then the columns on either end are typically not vertical, which creates all kinds of challenges, but fun challenges. You can see kind of the inside, how beautiful that is, and again, they're just depending on the cross laminated timber here was used as the roof, and it was also used as the walls between the columns. Again, more pretty pictures here at the end. True pin connection at the bottom. And I went through fast enough that I could save plenty of time for questions. And I hope that you guys have plenty of questions and didn't skip over things too fast for you.
Yeah, so if anyone has any questions, please throw them in the Q&A or throw them in the chat. This has been a very interesting presentation. So thank you so much for your time. I'll just, thank you while we're waiting for people to type, because hopefully everybody's cracking away at their keyboard. No, it's very interesting.
Yeah, I mean, who doesn't love something like this? Like this, I'll just keep talking about this showroom for a little bit. You know, the whole rationale behind making this showroom the way they did is, well, for one, you can see out the end. There's your steel columns in there, and then blue lam beam up top. If I went back to say this first picture, you can see that maybe a little bit better. Slow, yeah. So like there's our steel columns in there and a glue lam beam up top, and we created a steel glue lam moment frame out of that, which is really unique, really different, really fun. And these guys manufacture equipment. They sell equipment, basically sell manufacturing equipment. Their manufacturing equipment bends steel for things like refrigerators or washing machines or whatever. So if I were, a manufacturer of a washing machine, I might come into their showroom to see them make the parts that I need made on their machine that they're trying to sell me. So it's kind of trying to um, communicate that, hey, we're very creative people. This is a very creative structure that we're in, and our machinery is pretty amazing. So
Nice.
yeah.
Do have a question. It says some of these projects at the end were 2 to 3 stories. You mentioned 1 to 5 stories was not as cost effective as higher projects. What drove the owner to CLT on the MSU and the Hamilton projects, if you know?
Yeah, so the Hamilton one was the Italian owner, and they had built one similar to this out in Italy. So they wanted to build this one as well, the same way. And you can imagine again the difference of someone coming in to a pre-engineered metal building, which is what they were building onto. That used to be their showroom, was inside of a pre-engineered metal building. It's clean. It was, not bad for pre-engineered metal building, but there's a different wow factor when you come into a building like this. So that was their rationale. So was this cheaper than a pre-engineered metal building? No, heck no. But that's not the rationale for why they built this. So you have to have another reason to build it this way. There's plenty of reasons that you could potentially want to build it this way. the MSU building. So a lot of colleges are doing it because they want to, designing and building out of wood is far more earth friendly, shall we say. I don't know about far more. There's a lot of debate about that, right? How long is your structure going to last? How far do you have to ship it? How much energy is it going to take to manufacture that? But it's at least a renewable resource, and there's debate. Many people would say that it's more green than steel or concrete construction. So universities, a lot of the projects I've been working on are universities. So they see the younger generation caring about the earth, so they want to get on board with that. So a lot of universities are building mass timber buildings. So again, they have another reason for it. Might not have been the most economical, but it's also not terribly uneconomical. I'll say most of these buildings erected are around $40 to $50 a square foot. That doesn't include foundations, it doesn't include any finishes, but this could be your finish, right? So there's a lot of things to consider in the equations, including, you save 3 months on your schedule potentially, and that means 3 months less of loan payments or interest accruing on your loans and stuff like that. So or 3 months less of insurance that you have to pay during construction. So 3 months less before you start getting paid back, right? A lot of
And
different things going on, right?
yeah, schedules are pushing a lot of things. If folks can build stuff faster or easier or more efficiently, sometimes schedule will govern.
Yeah.
Um, one question is, how are you received by the lead community? Credits, compliance, certificates, that kind of thing. Have you?
How am I personally?
Well, how is
Oh,
not you personally? How is CLT and
yeah,
that
yeah, yeah.
and the
I would say the ones the most people that are very conscientious about designing designing of for have a heart towards the earth, I guess, are really drawn to this, because they're I think there's a strong argument. Again, there's a lot of people have strong opinions on this, but I think most people would agree that in general this is going to be more beneficial, and that it's a renewable product. Now, theoretically, if the building lasts forever, then you're actually so the trees that are cut down, um, they have pulled carbon out of the atmosphere, and as you regrow your forest, you've actually pulled carbon out of the atmosphere. Now, in 500 years, this building might not be here, and it may all rot away. But same is true from a tree. If it dies, or if it's in a forest fire or whatever, as soon as it decomposes, all that carbon goes back into the atmosphere. So I would say at least
yeah.
we're reusing resources that are
Do
actually
you
readily
happen to
available.
know if any of the projects you've worked on have been LEED certified?
Oh, I'm sure quite a number of them are, but I'm not sure if the Redstone was or not. I'm not sure. I'm sure
Okay.
that the MSU one was. Again, that being on a campus, that's something that's really important to them. Yep. And I don't know
Uh,
about this one here.
and we're sort of running out of time. I'm going to give you one last question. Limits and costs of transportation to CLT, are they similar to, say, precast concrete, or what kind of?
No, I would say not similar to precast concrete. I think precast concrete is way heavier for one, which means when you're transporting them, you've got a lot more fuel costs per mile on a precast than you would on this. This is about 30 pounds per cubic foot, whereas precast is around 60 pounds or 150 pounds per cubic foot. It might be slightly thinner panels than you would here, but not that much different. So you could use trains to ship this stuff. You can also just use trucks. But I know Nordic, for instance, has had projects in Colorado and in San Francisco. So shipping is not a major concern. However, you become less and less green the further you go, right? So those are all, again, like I said, it's a complicated thing as to whether or not it is more green or not, right?
Yeah. Thank you, Doug. This has been a great presentation. I'm just going to give a quick reminder, shout out to everybody. By the way, everyone, please mark your calendar for February 10th. We're going to be looking at VR and rendering design architecture and interiors and using VR on projects. So that should be a really great presentation. Thank you again, Doug. This has been fabulous. And thank you so much for coming and presenting to CSINext. We wish you all the best on your future projects. So
Thank you.
have a great day, everybody. And I will see all of you, my fellow CSINexters, in February. So bye.